Hey everyone, and welcome to another deep dive. Today we're looking into something pretty fascinating. It's called Stable Latent Reasoning, or SLR for short. Basically, it's about making AI even smarter. And to help us break it all down, we have an expert joining us today. Welcome to the show.
Thanks. Glad to be here.
So when we talk about AI getting smarter, what exactly do we mean? I mean, these AI systems are already doing incredible things, right?
Yeah, it's true. Large language models, those are the AI we're talking about, LLMs. They're already amazing at so many things, like writing poems or answering trivia. But when it comes to reasoning, like really thinking through complex problems, well, that's where they sometimes hit a wall.
So it's like they have all this knowledge, but maybe not the best tools to actually use it effectively. It's kind of like having a giant library, but no librarian to help you find the right books.
Yeah, exactly. And, researchers have been trying different approaches to improve this reasoning ability. One idea has been to just make these models bigger, kind of like thinking a bigger brain equals smarter.
Makes sense, but I guess that's not always the most efficient solution. It's like thinking if you add more lanes to a highway, traffic will just magically disappear. What else have they tried?
Well, there's something called chain of thought prompting, where you basically give the LLM hints or examples to kind of guide its reasoning.
Oh, so it's like giving them a step-by-step guide, like showing a student how to solve a problem.
Exactly. But even with these methods, LLMs still face limitations because they process language one word at a time.
So that sequential processing might make those multi-step reasoning tasks tricky.
Exactly. And that's where SLR comes in, offering a totally new approach.
Ooh, okay. I'm intrigued. So how is SLR different?
Well, it treats the LLM's inner workings, what we call hidden states, as kind of like continuous thoughts.
Continuous thoughts. That's interesting.
So instead of looking at language bit by bit, SLR allows the LLM to work with these thoughts, refining them over multiple steps, kind of like a sculptor refining a piece of clay.
Okay, I love that analogy. So the AI starts with a rough idea and then keeps molding and shaping it, getting closer to a solution. That makes a lot more sense than just processing one word at a time. But how does it know how to refine those thoughts? What guides that process?
That's where it gets really clever. SLR borrows techniques from other areas of AI to make sure things stay on track. One technique adds a sense of time to each step, inspired by those diffusion models used in image creation.
Wait, so creating images helps with refining thoughts? How does that work?
So in diffusion models, you add noise to an image and then train the AI to reverse that noise. And by doing that, it learns to create images from scratch. In SLR, this same idea helps guide the AI as it refines its thoughts.
So it's like giving the AI a roadmap for its thought process. Makes sense. What other techniques are involved?
Well, there's loopwise lore. It's like a specialized toolbox, giving the AI different tools for different stages of problem solving.
So the AI has a specific set of skills it can use at different points in its thinking. That's super smart.
And to prevent errors from piling up, SLR uses something called loop residual connection. This takes inspiration from a type of neural network called ResNets, known for its stability.
So it's like SLR is a mashup of the best ideas from across AI. It's using all these different techniques to refine those thoughts effectively.
Yeah, you got it. Researchers are really pulling out all the stops to make SLR as powerful and reliable as possible.
This is fascinating stuff.
Yeah.
But so far, we've only talked about refining these thoughts. How do you actually train an SLR model to do all of this?
Well, there are a couple of different ways. You could train the whole model from scratch.
Okay, but that sounds like it could take a long time and a lot of resources.
You're right, it can be pretty resource intensive. But thankfully, there are faster options. We can start with an LLM that's already been trained on a ton of data, and then fine-tune it specifically for SLR. We can even use existing data from that chain of thought prompting we talked about earlier.
So you can kind of give the AI a head start. It's like a student who already has a good basic education.
Exactly. And that makes the whole process much more efficient.
So we've covered how SLR works and how it's trained. But the big question is, how do we know if it actually works? How can we test if all this thought sculpting is making a real difference?
Good question. Researchers put these SLR models through a whole bunch of different tests, solving math problems, figuring out logic puzzles, even generating creative text formats, anything that requires that multi-step thinking we've been talking about.
And they're looking for.
Well, obviously, getting the right answers is key. But it's not just about that. We also want to see how efficient the AI is. Did it take fewer steps than other methods? Was the process smooth and reliable?
Right, because even if it gets the right answer, if it took a million steps and crashed a few times along the way, That's not very helpful.
Exactly. And we're also really interested in understanding how the AI got to its answer. Can we actually make sense of its reasoning process?
You mean, can we peek inside his thoughts and see what's going on?
Yeah, precisely. This is something called interpretability, and it's super important if we want to trust these systems.
It makes sense. I mean, if we don't understand how an AI arrived at its conclusions, it's hard to fully trust those conclusions.
Exactly.
This has been an incredible deep dive so far. We've learned about how SLR works, how it's trained, how it's tested, and that it seems like it really does have the potential to take AI reasoning to a whole new level.
It absolutely does.